Assalamu alaikum wa rahmatullahi wa barakatuh. In implicit differentiation, we can see you have to be given such a function with two variables, x and y, in the same function, and they'll ask you to find the gradient of that function, which is dy dx of that function. Now, given such a function, the rule of the technique that we can apply there is implicit differentiation. Now, how can we find dy dx in such function? Therefore, we just differentiate in terms of x, or the word function in terms of x. Now, what is the derivative of 2x squared? The derivative of 2x squared, it will be 4x. Then plus, what is the derivative of y squared? The derivative of y squared, it will be 2y. But because we are differentiating in terms of x, and this is y, we just put there dy dx to refer that what we are differentiating there was not x, was the other variable. Then we minus 1. What is the derivative of 4xy? Now we can see here, we have to apply product rule since there's product of two functions. So there's product of x and y. So since there's the product of those two functions, then we have to apply product rule to differentiate this. Therefore, the product rule says that we just take the derivative of the first function, we multiply by the second function. The derivative of 4x is just 4. Then we multiply by y. Then we add the derivative of the second function, which y, the derivative of y is just 1. Therefore, 1 multiplied by 4x, it will be 4x. But since we were differentiating y and it wasn't x, we have to write dy dx. Then plus the derivative of 6x is just 6 minus the derivative of 2y, it will be 2. But since we are differentiating y, we have to write dy dx there, which equals to the derivative of 3 is just 0. 3 is just a constant, and wherever you differentiate a constant, it just gives you 0. Therefore, we can simplify this function as 4x plus 2y dy dx minus 4y minus 4x dy dx. So plus 6 minus 2 dy dx equals to what? Equals to 0. We can collect like terms together. Whatever has dy dx, we can collect them together, and the rest we also collect them together. So let we take dy dx to the other side with 0. Therefore, 4x minus 4y plus 6 is just equals to, let's take 2y dy dx, and the other side to be minus 2y dy dx. Let's take 4x dy dx, the other side to be 4x dy dx. Then let's take 2, then other side to be 2 dy dx. But you can see we have dy dx as common on the other side. Therefore, 4y minus 4y plus 6, it will give us as dy dx into minus 2 plus 4x plus 2. Therefore, 4x minus 4y plus 6 is just equals to what? When we divide this one by minus 2y plus 4x plus 2, it will be equal to dy dx. Therefore, dy dx equals to 4x minus 4y plus 6 all over what? Minus 2y plus 4x plus 2. Therefore, this, it will be dy dx for such function. But our question was using implicit differentiation to determine the equation of the tangent to the curve. The equation is to find the equation to the tangent. Now, how can we find the equation to the tangent of the curve? We know that first we have to calculate the gradient. The gradient of that curve is given by this one. But we have given the value of the point as x to be 1 and y being 1. So we can get our gradient, and this gradient is the gradient to the tangent. This is the gradient to the tangent of that point, of point 1, 1. When we put the values of x and y at a certain point, then we will get the equation, the gradient of that line at that point, of this line at that point 1, 1. Now the gradient of that one, and that line, it is at the tangent to the curve. In this one, it was the point 1, 1. Therefore, the gradient of this line passing at that point is the tangent, is a tangent, meaning it only touches a single point at that curve. Therefore, dy dx equals to what? 4 multiplied by 1, which is 4, minus 4 multiplied by 1, which is 4, plus 6, all over, minus 2 multiplied by 1, which is minus 2, plus 4 multiplied by 1, which is 4, plus 2. Therefore, which equals to what? 4 minus 4 is 4, which remains 6. Then 2 minus 2 is 0. We remain with 4. Therefore, the gradient it will be just 3 out of 2. Now, we have this one has our what? Our gradient, m. Our m equals to what? 3 over 2. And we know that equation of a line is in the form of y equals to mx plus c, where y is the intersecting point of that line in the y-axis and m is the gradient. Now, how do we come up with the equation of a line? Coming up with the equation of a line, we have our m, which is the gradient, as 3 over 2. We have our y, our first point. We have a point 1, 1. So if we have gradient and a single point or one point, we have gradient of a curve and a point, then it is possible for we to obtain an equation of a line by adding another point, assuming that is x, y. Therefore, but we know that applying the method of calculating gradient, we know gradient is change in y, which is gradient. So gradient dy dx, which is the gradient, equals to change in y, which is y minus 1, y1 minus y2, or y2 minus y1, all over x2 minus x1, which it will give us the gradient dy dx as 3 over 2. Therefore, so cross multiply, it will be 2 into y minus 1 equals to 3 into x minus 1. So 2y minus 2 equals to 3x minus 3. But we know the form of equation that we need is in the form of y equals to mx plus c. Therefore, whatever is not x, we have to take it to the other side, whereby we remain with 2y as 3x minus 3 plus 2. Therefore, 2y equals to 3x minus 1. Divide both sides by 2, it remains 2 equals to 3 over 2x minus a half. Therefore, this it will be the equation to the tangent. And always, this is the gradient of that equation or that function. The gradient always should be m, which is mx, m the gradient. Therefore, that it will be our equation to the tangent.